Good morning, everyone. Today we are going to skip forward a little bit and go into Chapter 4. And we're going to be looking at, in Chapter 4, graphing in particular. And when we're looking at graphing, we're going to be talking about what we call the coordinate plane, sometimes also called the Cartesian plane. And what this essentially means is it's a graph, like what we're used to seeing. And it's called the coordinate plane because you're going to be dealing with coordinates, which is what we've been using to describe like our x, y there. Now don't forget, if you are the sort that tends to forget which comes first, the x or y, this is in alphabetical order, right? X, y, z, the x comes first, y comes second. And if you're looking at the graph itself, the x is going to talk about its horizontal distance from the origin. And our origin is this point right here. It's where the x and the y intercept, and that means both x and y are 0 at that point, our origin. And our y then, of course, is our vertical distance. And you can almost see y hints towards it because you see how y has that stem going down. It's telling you look horizontal, or don't look horizontal, look vertically. My bad. And x, of course, goes in both directions. So just you can remember that with the y pointing down to show you that it is going to be that vertical line. Now you might also know that notice that I added a few numbers around the corner here, and these are indications of our quadrants. Now, quadrants are formed by the x and y axis splitting the graph into 4 quad portions. The first quadrant is, of course, then quadrant 1. And in quadrant 1, you'll notice that x is positive and y is positive. So if I took a random point, let's say here where we have like 2, 2, both those are going to be positive. If you look at your second quadrant, notice they do move counterclockwise here. Our second quadrant, y is still positive. You can see it's up, but x is moving backwards. So that makes x negative. So we're going to have a negative x and a positive y. In quadrant 3, opposite quadrant 1, we're going to have all negatives here. So if I took a random point down here, this would be a negative 3, negative 2. If I took another point, I have negative 1, and then I could count down 1, 2, 3, 4, 5. Negative 1, negative 5. So notice how all of my coordinates here will be double negatives. And last but not least, if I'm looking over here and I picked a random point, like let's say this one right here, that would be a positive x, 1, 2, 3, 4. And I know it's positive because I'm going towards the right. And be a negative y because I'm going down, and down is negative. So we're getting positive x's and negative y's. So this is a nice indication that you're graphing correctly. If you know which value is positive and which value is negative, you'll know at least what quadrant you're supposed to be in. And of course, if it's neither positive or negative, that means it's 0 and it is either on the x or y axis. And we'll look at examples of that in a little bit. But first, let's just find what coordinates each of these points are at. And when you're doing this, make sure to organize your information. I seem to be missing a point. Oh, here it is. And what we're going to be doing here is just looking at them one at a time. Now remember, in your coordinate, x is going to come first, so you're going to have to count over how far did you go. And watch your scale. It will tell you how much you're going up each time, because I could be going up by 2's each time, I could be going up by 1 for every box I go over. And for this one, if you look, it does look like we're increasing by 1, because that'd be 1, 2. All right, so A is 2 over and 7 up. And you can physically count it or just line it up with the nearest dash. And since this is between 6 and 8, it must be 7. Now B, notice I'm going backwards with x, so I am going to be in the negatives. In fact, B is at negative 4. And remember that x horizontal movement has to come first. And we go up 6. For C, we are at the origin, so that's going to be 0, 0. D, it looks like I'm going back 3, so that's going to be negative 3. And I'm going down 3, so that's negative 3. And I'd be done there. And then E is, oh, see how this one is not actually over at all. It's exactly on the line. Since it's exactly on the line, that means it's at 0 for x because we didn't move it over sideways. But we did move it up 2 from the origin, so we're at 0, 2. And last but not least, f is going to come all the way over to 7 and drop all the way down to -5, so it's a +7, -5. Now, what you might notice when you're looking at these is you can actually identify which quadrant each of them are in with or without the graph. It doesn't matter which, because if I know both of them are positive, I know it has to be in quadrant 1. So I can actually add the quadrants behind these even without looking at the graph. If x is negative and y is positive, I'm on quadrant 2. If we're at 0, 0, well, that's the origin. It's not in a quadrant, it's overlapping. If I'm at negative, negative, well, that's quadrant 3. In fact, you can see it's in quadrant 3. Remember, either way works. 0, 2, well, 0, 2 is not in a quadrant. What it is it's on the y-axis. And I know it's on the y-axis because you can see it literally sitting on the y and not on the x-axis, of course. And last but not least, I've got a positive, negative, which you can see then is in the 4th quadrant. So those are the key elements of a coordinate plane. And we're going to use it to graph a bunch of things. And we've been doing some graphing. We've done some in the past. And one of the questions that pops up a lot is, how do I know what values to make x and what values to make y? So for instance, if we're looking at what year it is versus how much a company spends, like which one should be the x and which one should be the y is really the question that we're asking. And here's the key part with that. When you're looking at x, you're looking at what we call the independent variable. And of course, variable is just a number, or I'm sorry, a letter representing some random number. And independent means it stands on its own. And that's in contrast to y, which we're going to have as our dependent, it needs dependent variable. Now, what does that mean practically, though, if x is independent and y is dependent? What it means is that x is the one that we have first. It's like what you know or can manipulate. And the dependent is what you find out. It's a kind of our second part. So for instance, if I'm looking at year versus spending, well, which one do I start independent, like have first? Which one is something that I will just automatically know? Well, I know the year automatically. Like I can't really change what year it is. And which year it is, though, does affect how much spending there will be. How much spending there is does not affect the year. Therefore, because the one that I have first is time or year, that indicates that that must be x. And since spending is the one that I find out, that must be y. And again, when you're looking at independent versus dependent, that's another way that you can consider it. The year will affect how much we spend, whereas how much we spend does not change the year. So spending is dependent on year, but year is not dependent on spending. So year is what we call an independent variable. It doesn't get affected by the other. And you can, of course, do that with a lot of different things. And sometimes it can be really tough to tell which one is independent and which one is dependent. And a lot of that will depend on what you're trying to find out, because what you're finding out will be why. So read those questions carefully, because it will change the shape of your graph if you have those switched. But we do know from what we just found that x is year and y is spending. So I label those right away. So I know that when I'm making my coordinates, I'm going to have x as year, y is spending. And what we're going to make is what's called a scatter plot. And a scatter plot is just a bunch of points scattered across the graph. You're plotting in a scattered pattern. And what you're trying to do when you do a scatter plot is you're trying to take a bunch of information that you're not really sure how it fits together or what it looks like, and you're trying to find an underlying pattern. It won't necessarily be nice and neat, but you can usually find a general shape in whatever you graph. So what we're going to do then is start our graphing. And with this, you're going to first have to start by finding what a good scale will be. And when we're going up by years, a lot of times it's good to do years after a certain decade. And since we start at 1990, let's just say that X is going to be on our graph the years after 1990, which means, of course, 1990 will be at the 0. And then we can do 1, 2, 3, 4, 5, 6, and 7. Of course, I don't have 7, but that's okay to have on my graph. Now, our second thing is going to be spending. And notice that we go from 300 to 970. So from about 300 to almost 1,000. Now, this is quite a small graph. So that means my scale here is going to end up being quite big to get that huge range, that huge difference between 300 and almost 1,000. So let's just try going up by hundreds real quick. This would be 100, 200, 300, 400, 500, 600, 700. So not big enough to get my 970. So I'm going to probably have to go up by 150 or by 200. Now personally, I prefer 200 just because it's a nice number to increase by. It's something that our brains easily recognize. So let's go up by 200. And what this is going to allow us to do is get all of our graphing on this graph. And so always check first what sort of scale you're going to need in order to fit it on the graph that you have. Now, if you find this and you're like, I really don't like this scale, I'd like a bigger one, you can adjust your graph accordingly. And notice that we are only in the first quadrant, so really you could redo a graph that only has quadrant 1 shown in any sort of detail, because both of our numbers are going to be positive for all the information that we have. But let's start graphing then. So at 1990, we're at 0 here because it's years after, and we want 322, so that's going to be about here. For our next one, 1991, we're at 362, so that's just a little bit higher on here. For 1992, we're at 391, so almost at that 400 mark. For 1993, we're at 515, which is a pretty big jump, putting us about here. 1994, we're at 715, again a pretty big jump, and that's going to be at about here. 1995, where my 5 is, we're at 924. Look at that increase. It's going to place us right about here. And last, 970 is going to place us right along here. Now, what we're going to then be able to do is kind of see the overall pattern. And if I were drawing in a pattern here in pencil, I'd have like, well, it's a slow increase that goes rapidly and then just starts to slow again, right? That seems to be what's happening, and that's frequently what we do when we do a scatter plot, is we play a little bit of connect the dots, but we don't worry if we miss a point or not. And so that's different than normal graphing, because it's okay if, you know, like this one's a little bit higher than where you'd place a line, or this one's just a little bit lower. You're estimating where a line would go through. And if I look at describing the relationship between time and spending, I can make general observations. And basically what you're going to say is when X, in this case time, increases, what happens to Y? Y does what? And in this case, Y is spending, and we can see that spending also increases. And that's going to be your general formula. Say when X, and then say what it actually is. You can just say when time increases, Y increases as well. And now if you had seen a pattern where it was like this, where X, as X gets bigger, right, as we go towards the right, Y will be decreasing. That's what you would say instead. When X increases, Y decreases. And we can also see from our graph, or even our table, what year had the lowest spending. And the lowest spending is at 1990, because that's the smallest number. And the highest, if we look at our graph, is 1996. And you can confirm that on the table. And last but not least, a lot of times the thing that's really nice about scatterplot is it allows us to make predictions about the future. Now, those predictions might not be accurate, but they can come in handy. So what would you estimate your spending to be in 1997? Well, it looks like it's coming really close to 1,000. So I'm going to guess that the spending will be 1,000, and I'm going to use some units there as well. All right, guys, your homework for today is right here, page 206, 18, 33 through 35. There are some graphs attached online. I hope you guys have a wonderful day.